So good morning students, and we are going to start with the chapter which we have already completed in unit 3. Yes, it is light, reflection and refraction topic. Yes, we have completed reflection and we are going to start with the refraction. Yes, so you can see that these are two different terms, isn't it? Reflection and refraction. So now we will be starting with the next concept, and that is called as a refraction. Okay, so first of all, you tell me, how do light travels? Yes, you know this in your previous classes you have learned. How do light travel? Light travels in a straight line, right? So, whenever you see that light is coming or the light rays are coming, you know that it travels in a straight line. That is why you are not able to see what is there in the corners of the room or what is there behind the walls, isn't it? Okay, but then whenever you take any of the glass in front of you, which is not a transparent glass, which will be having a little bit of thick surface, or there is some design on the glass, and if you try to look through that type of a glass, how do you see yourself, or how do you see if you keep your fingers behind the glass? How do you see your fingers? Do you see them in a straight manner, or how do you see your fingers? Yes. Or if you try to see any object through the glass, how do you see that object? Is it clear? Or the object appears a little bit bended, or the object appears a little bit uh, not in a straight way? Yes. Do you see that bend rays in between, or do you see the object in a different manner? Yes or no? Yes. Isn't it? Okay, so we are going to learn the similar phenomenon here in case of the refraction. So let us understand what is a refraction through a rectangular glass slab. We are going to see what is a glass slab. It is just a simple plain glass slab. Okay, it is a simple, you can say a piece of a glass. Okay, so let us see that we know that light travels in a straight line. So this light ray would normally travel ahead like this. We call it as a propagation of light. Right? Light is moving ahead in a straight line. Correct? So if we have a transparent glass slab, you take any of the transparent glass piece and if you place it in between in a way of a light, then the light would travel through it but in a different manner. Okay? So how do this light will travel? So you know that a common ray of a light or common or the general way is that the light will travel in a straight line. But if you put a glass slab in between, the path of this light ray will change in such a situation. So what has happened here? The light ray bends a little bit and then it will move ahead. Okay, so every time whenever the light will go from one transparent medium to the another, it will bend. So here is the air, correct? You are trying to focus these light rays from air and you have kept a glass medium in between. So what has happened? From one transparent medium, these ray of light, they have traveled into another transparent medium. This is another, glass is another transparent medium, correct? And then they will leave that transparent medium. Again, they have entered into the air. So now you can see that light rays bend a little bit. Got it? So this bending of a light as it travels from one transparent medium to another is called as a refraction. Understood what is a refraction, everyone? Whenever the light travels from one transparent medium to another, and that time the light will bend a little bit, that is called as a refraction. Got it? So whenever you try to see through a very clear water, whenever you try to see through the windows, why you are able to see through the windows, or why you are able to see through the water? Because the light rays are traveling through the medium. Okay, the light rays are passing through that transparent medium, and that is why many times you must have seen that if the water is very clear, you can see the bottom of the river, you can see what is there at the bottom, isn't it? Why you can see? Because the light rays are traveling through that transparent medium. Getting it? So this phenomenon is called as a refraction. Right? It happens only in case of transparent media. Getting it, everyone? So have you understood the reflection and the refraction? Reflection is what? The light rays will not pass through the media. Instead, it will bounce back. Right? So you can see the image. But in case of refraction, what happens is the light rays will travel through the transparent medium, and that is why you can see through that object. So glass, water, any other liquids, we are going to see different types of liquids. There are different examples given in the textbook. We will be understanding those also. Okay, so that is called as a refraction process, or the phenomenon is called as a refraction. Now, let us understand this refraction in more details. Now see here. Mark point B and C where the light enters and exits the glass. Now can you see this solid line which is passing here? Forget about this dotted line now, okay? Just see this solid ray of a light. It is entering into the glass slab. Okay, we are going to mark these points here. And on this point, you can see the light ray is exit. It is taking exit through this glass slab. So we will be marking this point B here. And when the light rays are coming out of this glass slab, you have to mark C here. Now, if you try to draw a normal, what is a normal? A perpendicular line at point B and C here. What can you see? What is happening to the B point here? Can you tell me now? This is a normal. This is a green line. You can see that it's a normal, right? This is a perpendicular line which we have drawn on both the points. How is a ray of a light here? When the light rays are entering into the glass slab, what can you say about this ray of light with respect to this normal? And what can you say of this ray of light with respect to the normal? Can you tell me something? Yes, any one of you? If you can see clearly, what can you tell about this here? See, whenever the light rays are entering into any of the transparent media, and if you see the normal is here, the light rays are bending towards the normal. Getting it? When it is traveling from one transparent medium to another, that means from air to glass, when the light rays are entering inside, you can see that when the light is bending, it is bending towards the normal. Right? Now tell me, what has happened to the light ray here at point C? So what is happening to this point C here? The light rays are moving away from the normal. Right? Okay. So here at point B and at point C, you can see the light traveling is different. So light just travels ahead in a straight line through the glass slab. But at point C, you can see that light will bend away from the normal and then it is coming out into the air. Isn't it? So you can see actually the light ray, when it is traveling straight in a glass slab, it should have this direction. Right? It should move in this direction. But then what is happening when the medium is getting changed? It is bending away from the normal. Correct? Okay. So bending of light as it travels from one transparent medium to another is called as a refraction. Have everyone understood what is refraction here? What exactly happens in refraction? Yes? Any doubts? Any confusion? Okay, so refraction happens because speed of a light changes as it enters from one transparent medium to another transparent medium. Okay, why refraction will happen? It is written very clearly that because the speed of the light will change, right? Because it has to enter some denser medium. As you know that air and glass, both are different media, isn't it? So denser medium, glass is more denser medium. So what will happen to the speed of a light? It will slow down. So the speed of a light will change as it is entering from one media to another transparent media. Right? So that is why this refraction phenomenon will happen. Now let us go to textbook. This is page number 174. Everyone please open page number 174 from the textbook. So we are going to read these laws of refraction. So you must have learned the laws of reflection in your previous unit. Everyone has understood those laws of reflection. In the same manner, we are going to learn about these laws of refraction also. The first law, you said that it should be an angle of reflection. Okay, angle of incidence is equal to angle of reflection. Okay, and second law is the incident ray, normal, and the reflected ray, they lie in the same plane. These are the two laws of reflection you have learned. But now we are going to learn about the laws of refraction. Now, what are these laws of refraction you can see here? First law is, you can see here, the incident ray, refracted ray, and normal to the interface of two transparent media at the point of incidence all lie in the same plane. Getting it? The incident ray, refracted ray, and the normal to the interface of two transparent media. We have seen the normal which we have drawn at point B and point C. Isn't it? So that is the normal which is their interface. Interface means what? The glass slab and the air, where that is the interface where the light rays are actually entering and taking exit from the transparent media. So that is called as the interface. So at that interface, whenever we have drawn the normal, those three things are lying in the same plane. Correct? And second is the ratio of sine of angle of incidence to the sine of angle of refraction is constant. When it is constant? For the light of a given color and for the given pair of media. So if you are taking air and glass, the refractive index you can say, or this ratio of angle of incidence and angle of refraction will be constant. Now we will be reading section 10.3.2, the refractive index from page number 174 and 175. Okay, let us read that. Everyone is with me? Please pay attention, everyone. Yes. So now let us read this refractive index. Now what is this refractive index? We have already studied that a ray of light that travels obliquely from one transparent medium to another will change its direction. Isn't it? Just now I have explained you about the change of the light rays, the path of the light rays when the light rays will enter from, or the light rays will travel from one transparent medium to another. So the extent of the change in the direction that takes place in a given pair of media may be expressed in terms of refractive index. The extent of the change means what? How much light bends. Okay, that is called as the extent to which there is a change in the direction of the light rays. So that extent we are going to explain in terms of refractive index of those particular two media, and that is called as a constant. Okay, you can see here this ratio, whenever you will take, that ratio is always constant whenever you take any of the pair of transparent media. So the refractive index can be linked to an important physical quantity. So that is a relative speed of propagation of light in different media. What do you mean by propagation of light? Movement. Light is moving ahead. Correct. So how do you express this? What is the refractive index? It is linked to the relative speed of the propagation of light in the different media. How the light will move ahead, or how light will travel in different transparent media. Okay. Depending on this, the refractive index is calculated. Obliquely meaning anyhow, randomly. Yes. So it turns out that light propagates with different speed in different media. So in different transparent media, if you take, the light will have a different speeds. So in air, light will travel with a different speed. In glass, light will travel with a different speed. If you take any other transparent media like water, light will travel with a different speed. Okay, so it is like light propagates with different speeds in different media. So light travels fastest in vacuum with the speed of 3 into 10 raised to 8 meters per second. Okay, this question may come for your MCQs. So you have to remember this, that light travels fastest in vacuum with the speed of 3 into 10 raised to 8 meters per second. So in as compared to vacuum, in air, the speed of the light is marginally less. Getting it? So where is the speed of the light is fastest? It is fastest in vacuum. Correct? And in air, as compared to vacuum, in air it is less. So the value, you can see, it reduces considerably in glass or water. So even more less speed of light is there in glass or water. So the value of the refractive index for the given pair of media depends upon the speed of light in two media as given below. So we will consider the speed of a light in two different transparent media whenever we have to calculate the refractive index. Getting it, everyone? Till here, what is a refractive index? Or should I explain you again? So let us understand the next term here. How do you calculate that refractive index? Now, if you consider a ray of a light traveling from medium 1 into medium 2. Okay, now you can see this 10.11 diagram here. This is medium 1. Okay, this is air, and this medium 2 is a glass medium. Both are transparent medium? Yes. Let V1 be the speed of light in medium 1. Okay, speed of light in medium 1, that is in air, the speed of light is V1, and V2 be the speed of light in medium 2. So how will you give the refractive index here? So the refractive index of medium 2 with respect to medium 1 is given by the ratio of both the speeds of light in medium 1 and medium 2. And this is usually represented by symbol N21 at the subscript. Why 21 is written here? Why N21 is written here? Because this is with respect to medium 2 to medium 1. Got it, everyone? So whenever you are going to write N21, you will be writing it as speed of light in medium 1 divided by speed of light in medium 2. Right? So that is why the refractive index will be given here as N21, because this speed of light will be in medium 2 with respect to medium 1. So this will be the refractive index. So by the same argument, the refractive index of medium 1 with respect to medium 2 will be given by N12, because it is speed of light in medium 2 divided by speed of light in medium 1. So it will be V2 divided by V1. Got it, everyone? So if the value of speed of light in medium 1 is given, that means in air the speed of light is given, divided by speed of light in glass is given. So you are going to calculate this. So you will be getting the refractive index of the glass with respect to air. Got it? Instead of air, the medium 1 can be other transparent media. For example, instead of air, it can be any other liquid also. Correct? So the speed of light in that particular liquid, you are going to write here. The speed of light in glass, you are going to write here. And if you take that ratio will be the refractive index of glass. Got it? Similarly, you can do it for N12 with respect to 1 to with respect to 2. That also you can write down. Okay, so this ratio is constant. This is called as the absolute refractive index of the medium. Getting it? This is called as absolute refractive index. If medium 1 is a vacuum in air, sorry, this one. If medium 1 is a vacuum in air, then the refractive index of medium 2 is considered with respect to vacuum. Right? So this is called absolute refractive index of the medium. What is absolute refractive index? Yes, what is absolute refractive index? It is, yes, anyone? Absolute refractive index is actually when you are taking medium 1 as a vacuum or air and the refractive index of medium 2 is considered with respect to vacuum, then it is called as a absolute refractive index, and it is simply represented by N2. Okay, so I hope this is understood, everyone. Is there any problem? So we will stop here for today. Yes, and tomorrow's class we will continue the same chapter.
If you like our videos, do share them and subscribe to our channel. If you want awesome quizzes, write to us. Keep watching and keep learning with Walnut.